This is Math 141, Practice Test 2, problem number 17. Situation, I have a certain element whose half-life is 1,590 years. It has an initial mass of 150 milligrams. I want to know how long it will take for it to decay, so there's only 25 milligrams left. So there's two routes I could go with this. Actually, there's several routes I could go with this. I'm just going to think about it this way. My initial... grab a pen. My initial amount, well, the amount that I have at time t is going to be my initial amount times, and I could either do a 2 or a half its half-life. So I'm going to go 2 to the power of negative, because it's decaying, time, how much time it takes, divided by the actual half-life. Like how long it takes for it to cut in half. So setting that up, that half-life is 1,590, and my initial amount is 150. So if I start with 150, that's going to be 2 times its decaying, the number of years divided by 1590. And notice we do this because, like, when I'm at 1590, this is a -1, so it gets halved. And then double that 1590, that would be a -2, so this gets halved twice. You could write your equation that way. You could write your equation this way too. 150 half, and then to the power of t to the 1590. These are both equivalent to each other, because remember that negative exponent flips the fraction. Same thing. I'm going to go with this one. But we're just curious how long it takes this thing then to decay to 25 milligrams. So I'm going to solve this. First thing I'm going to do is divide both sides by that 150. And if I do that over on the left, you don't have to reduce it, but 25 over 150 is 1/6. That's just a 1. Is the same as 2 to the negative t over 1590. Sorry. Great, so now I have 2 to some power is equal to some number. So I'm going to rewrite this as a log base 2 statement. So log base 2 of 1/6 is negative t over 1590. And if I keep going to solve this, I'm going to multiply both sides by negative 1590. I'm trying to fit all that in that. Negative 1590. Sorry, I'm out of screen. Negative 1590. So I get a little space over here. What that does is then it leaves me with negative 1590 multiplied by log base 2 of 1/6 is equal to the time. And I can calculate what this is using change of base formula, then multiply it by that negative 1590, do that on my calculator, and I'm going to get about 4,110 years. So that's how long it should take this element to decay to 1/6 of what it was.